Hey everyone, today we're looking at how to convert from standard form to graphing form. The last video showed graphing form to standard form, which was pretty straightforward. This way, going standard to graphing is a little bit more complicated, and I believe that this is the easiest way to do it. There are a couple other ways, but I think completing the square, which is what we're going to do, is the easiest way. So for completing the square, the way I'm going to teach it to you is by using algebra tiles. And as you get better at this, you don't necessarily need to draw the algebra tiles, but I'm showing you this as a representation first. So the algebra tiles, you may have seen these in Algebra 1 or in pre-algebra. The algebra tile, if you have a square that is x units wide by x units tall, that is an area of x squared. So this is the x squared tile. If you have a algebra tile that is x units tall and 1 unit wide, 1 times x is x, so this is what we call the x algebra tile. And then if we have a tile that is 1 unit tall, 1 unit wide, that has an area of 1, 1 times 1 is 1, we call that the 1 algebra tile. So here are your steps to going from standard form. So if you look at example 1, there's something equation in standard form. We want to get it into graphing form. Here are our steps. So your goal with completing the square is to create a square using the algebra tiles based off of the given equation. Okay, so it seems pretty straightforward. So step 1, you're going to draw the x squared tile and label the base and height x. So if you look at our equation here, example 1, we have one x squared tile. So I'm going to draw one x squared tile. Remember, x is any length. So even though I have grid lines here, eventually we're not going to do it with grid lines. I'm just showing it to you. X can be any length. So I'm going to make x just 3. So I'm making a 3 by 3 square here. And it doesn't matter. It can be any. And I'm not labeling it 3. I'm labeling it x. X and x. X times x is x squared. You can make this any size you want. But again, you're always labeling it x times x and x squared inside there. That's step 2. Step 3, remember, squares need to have equal side lengths. Therefore, divide the coefficient of the x by 2. Draw that many x tiles on either side of the x squared tile. Label the base and height of your diagram now by adding or subtracting the number of x tiles that are connected to each side. So again, we're trying to make this into a square. So the coefficient of the x is right here. You're always going to divide that in 2. Divide that by 2 because we have 2 sides that we have to go off of, here and here. So 8 divided by 4 is, 8 divided by 2 is 4. So I'm going to draw 4 of those tall x algebra tiles going this way. And then I'm going to turn those algebra tiles sideways and put 4 going this way. So notice how I've turned them sideways and building them this way now. All right, so here's where we're labeling like it says. It says label the base. So remember, these are x units tall, but these algebra tiles are only 1 unit wide. So this is 1, 2, 3, 4. So this actually has a length here. This is 4 units long because those algebra tiles had a width of 1 unit. So I'm going to call this x, and since this was a plus sign, I put a plus, x plus 4. I'm going to then go down this way, 1, 2, 3, 4. Again, this would be x plus 4. Whatever the sign is of that x is the signs you're going to put here. Again, these were x units wide, but only 1 unit tall, 1, 2, 3, 4. All right, so here is the magic moment. You need to figure out how many ones blocks, these little tiny 1 blocks, you need in order to complete this square here. So that's why it's called completing the square, because we notice here, boom, 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 kind of draw this. We need to figure out how many of these 1 blocks fit in here to make it a square or to complete it into a square. we're going to multiply to find the missing area. The missing area, the area is missing, so it will always be negative. Okay, so this is like we owe the square this amount. So anytime you owe someone something, it is a negative amount. So this is 4 units wide, 4 units tall. 4 times 4 is 16. So I'm missing 16. And if you're missing anything, or we owe this square 16 in order to complete it, so it's going to be negative. This number is always negative no matter the signs of these. We owe it that. That's what it's missing, so it's negative. All right, we're almost done, but this is pretty cool so far. That's why it's called completing the square. We get to make it a square. 5, think of the area. Think of the square as an area and write your final equation. It should now be in y equals a parenthesis x minus h squared plus k form after combining like terms. And again, eventually you will be able to do this all in your head, or you may be able to do this all in your head without algebra tiles, and that's fine with me. If you like doing algebra tiles all the time, go ahead and do it. I honestly still draw algebra tiles a lot. It just helps me. All right, so now this is what we're talking about. We're writing this as an area. So I'm going to write y equals. So if this square area was a square, it is x plus 4 wide, x plus 4 tall. Remember, x plus 4 times x plus 4. Another way I could write that is x plus 4 quantity squared. And then we don't have that full area though, because we're missing 16 from there. So I'm going to write minus 16. But if we go back to the original equation, how many do we have? We have 10 plus 10. So therefore, I just combine my like terms at the end. Y equals x plus 4 quantity squared minus 6. And we now have it in graphing form. You may think that that took a little bit of time to do, but that was our first one. We went step by step. And if we double check our work here, if I graph x squared plus 8x plus 10, and then x plus 4 quantity squared minus 6, we see only one graph. And if we double check on the table, we notice that all those values are the same. So they are equivalent to each other. All right, one more example. So I have 1x squared. Remember, I'm always going to draw that squared first. And eventually we're going to not have graph paper. So you're just drawing a square. We label it x by x. We always cut that middle term in half. Half of 4 is 2. So I got 1, 2. Turn them sideways. 1, 2. So this is 1 unit, 2 units wide, 1, 2 units tall. Now the difference between example 1 and example 2 is that example 1 we have a plus sign for the x's. Example 2 we have a negative sign for the x's. And remember I said your sign of these numbers are always the sign of that x. So since that was a negative 4x, these are going to both be negatives, x minus 2 and x minus 2. Again, this is the drum roll part. We're completing the square, why it's called completing the square. So it's 2 units tall, 2 units wide. So 4, 2 times 2 is 4. And again, that's what it's missing. Anytime you're missing or owe it, it's a negative value. So this is always negative here. And now we go ahead and start writing in graphing form. So this whole area would be x minus 2 times x minus 2, or x minus 2 quantity squared. We are missing 4, so I put minus 4. How many 1s did we have from our original equation? Plus 9. All right, and then we combine our like terms, and our final equation would be y equals x minus 2 quantity squared plus 5. Tomorrow we're going to get into more details of this completing the square, different tweaks and nuances of it. But for now, that's the basics. Hope you like it.